Okay, today we're going to be starting section 12.5, talking about the law of cosines. The law of cosines is a little bit more complicated than the law of sines. So we only use the law of cosines when we're not able to use the law of sines. Same thing still stands true here, though, that when you're using any of the given measures, angles or sides, to find all the unknown side lengths and angle measurements of a triangle, that is called solving the triangle. Okay, so the directions for these are going to say solve the triangle. And so essentially what they're going to want us to do is find all the missing side lengths and all of the missing angle measurements. Okay, so for the law of cosines, please keep in mind that the lowercase letters represent side lengths and the capital letters represent angle measurements. So we use the law of cosines anytime you're given two sides and you actually know the included angle in between the two sides, or anytime you are only given all three sides and you know none of the angles. Now, I should mention here that when you are given all three sides, it is of the utmost importance that you always choose to find the largest angle first. Obviously, the largest angle would be the angle that would be opposite the largest side that you were given. Okay, we'll be able to talk through that here, but I want you to look at how the law of cosines works. Once again, remember all these lowercase letters are side lengths. There's only one spot where you put an angle measurement, and that's after the cosine here. Okay. Typically, these are all generally the same format here. If you're solving for a missing side, the missing side would be the side that would be on the left-hand side of the equation. So either side A, B, or C. Obviously, notice these are all squared here. Okay. And then if you're solving for a missing angle, obviously you would need to make sure that you choose the version of these three that has that missing angle. Now, one thing I do want you to notice on all three of these versions of law of cosines is that whatever side length is squared over here on this side, notice that that is the same angle measurement that follows cosine. Okay, so if you have b squared here, see how it's cosine b over there. If it's c squared, it is cosine c. Okay. And then in terms of what goes in the middle, if you're using up side a squared here, then this is b squared plus c squared. This is always a minus 2 times, and then it's those same two side lengths that we just used here. So b squared plus c squared minus 2bc, cosine, same angle measurement opposite this side. Okay. If you're using side b here, then it's the other two sides, a squared plus c squared minus 2ac. Again, this angle measurement is the angle opposite the side that you're given. Okay, it is very important that in these sections, law of sines and law of cosines, that your calculator is in degree mode. So we're going to go ahead and dive in here with this first example, and you'll notice that in this first example, the information that you're given, and we have a nice picture here drawn for us, we would not be able to use the law of sines to solve, at least start solving this triangle, because we don't know both an angle and a side opposite the angle. We have an angle, we don't know the side opposite. We have a couple sides, but we don't know the angles opposite those. And so this is where we're forced to use the law of cosines. Typically it's used for side angle side and side side side. I don't know that you need to necessarily memorize these go with law of cosines. I would say always tackle the problem where always try to use the law of sines if you can, and then if it feels like you can't set up something for the law of sines to work, then you're going to be forced to use the law of cosines. Okay, so it feels like on this problem, for us to be able to move forward with using the law of sines, we know this angle 36 degrees, but we need the side opposite, angle B. And so that's what I'm going to focus on here. I'm going to find side B. Okay, so I'm going to focus on maybe using this version of the law of cosines. I'm just going to jot it down generically here first. B squared equals a squared plus c squared minus 2ac times cosine angle B. Okay, and I'm after finding side B, so I'm putting the b squared on the left side. Everything else I should be able to fill in. Side A is 7, so I'm going to square that, plus side C, that's 5, I'm going to square that, minus 2 times side A times side C, cosine angle B is 36 degrees. You can see on this problem, we have no variables now on the right-hand side. So you should be able to pick your calculator up, type this entire right side into your calculator. Okay, now keep in mind though, when you type that in, you should see something similar to the number 17.3688. That is not side B. You then have to take the square root of that number. And I suggest that you use the answer feature. If you hit square root and then hit the second key and the negative button, it should say ANS above it. It will keep this whole decimal intact. And then at the end of that, this is where we would want to do our rounding. Side B looks like we're getting 4.17 units. Okay, as always, I want you to always add these as you find them onto the picture. Okay, now the beauty, at least, of law of cosines is you should only ever have to use law of cosines one time in the problem. Because once you find one missing component, now we have enough information that we can press forward with using the law of sines. Because I now know an angle, 36, and I know the side opposite that, 4.17. So I'm going to use that with law of sines. All right, so the best advice is to always, as you're finding these angles, try to find the largest angle first. So I have two sides here, a side that's 7 and a side that's 5. The bigger angle will be opposite the larger side. So I'm going to find angle A first. I'm going to set up sine of A divided by 7. Then we're just going to simply cross multiply. I'm going to divide by 4.17 here. Okay, and we said anytime we are finding a missing angle, we have to do the inverse trig function to kind of cancel off that trig function from the angle. So you're going to type in inverse sine of 7 sine 36 divided by 4.7, and that would give you an answer for angle A to be 81 degrees if we rounded it all the way up. Okay, 81 degrees. Okay, you don't have to worry about the whole 0 triangles, 1 triangle, or 2 triangles unless the problem asks about that. And those are exclusively with like the side angle law of sine problems. Okay. All right, now that we know two angles, this gets even easier to find angle C. We're simply just going to add up the two angles that we are given. Okay, that totals 117. We subtract that off of 180. That means angle C has to be 63 degrees. We add that to our picture just to kind of complete everything. There we have a completed picture with all the completed parts there. Okay, let's go ahead and try another one there. Okay, that is one where we use the law of cosines to find a missing side. Okay, all right, so here we are on this one. I'm going to go ahead and sketch a picture since we don't have a picture sketched for us here. This is triangle FGH. We're given that angle G is 82 degrees, side F is 6, side H is 4. Okay, you always have to draw a picture if one is not provided for you. You can see here what the information we're given is side, angle, side. We don't have enough information to start this problem anyhow using the law of sines, and so I want to try to find the side that is opposite the one angle we're given, and that would be side G. Okay, so as I look back up here, even though they used A's, B's, and C's here, if I'm finding side G, I'm thinking I need to be having a G squared on the left side, and my other two sides are going to get squared here, and then just multiplied together after the 2 here. Okay, so I'll keep this last law of cosines here within view so that we can see that here. Okay, so I'm going to be setting up G squared equals, okay, my other two sides are 4, so I'm going to square that, and 6, I'm going to square that, minus 2 times 4 times 6, and then cosine angle G, that would be the 82 degrees there. Okay, same thing as the problem before. You should be able to type this entire right side into your calculator. Just keep in mind that that answer is G squared, not G. Okay, and then I advise that you use the second answer feature when taking the square root. Rounding to 2 places, we get side G to be 6.73 units. We're going to add that to our picture, and then we can press forward, which is using the law of sines. So I'm going to be setting up sine of 82 over 6.73. I want to find the next largest angle, and that would be angle F. That's opposite side 6, so sine of f. Okay, and then this is the same process that we have used before with just cross multiplying. Okay, so we divide by 6.73, and then we're doing the inverse sine of both sides. This is going to give us the measure of angle F to be 62 degrees. Okay, we add it to our picture, we add it to our blank line. Then, now that we know two angles, we don't even need the law of sines to find the third angle. We add those two up, subtract off of 180. That gives us our remaining angle to be 36 degrees. 36 degrees. Add it to the picture and put it on the blank. Okay. All right, let's take a look at example 3. Okay, here in example 3, I'm going to go ahead and sketch a triangle here. We're going to call this A, B, C. Now you can see the information you're given in this problem is a little bit different. This is a side, side, side problem. We're given all three sides. Side A is 16, side B is 9, side C is 10. Okay, on a side, side, side problem, you must find the largest angle first. Okay, always find the largest angle first. The largest angle in this problem would be angle A. Okay, now remember the way that the law of cosines looks. Okay, the one that has angle A in it looks like this. Okay, so here's where our variable is. Our variable is going to be over here on this side. Okay, so we're going to plug in, we know side A is 16. That gets squared over there. Okay, we're going to fill in our other two sides. Doesn't matter the order, we put those in. Okay, minus 2 times this, and then cosine angle A. So what we're after is we need to get this cosine angle A by itself. So we've got a lot more algebra that we're going to have to work through on this particular problem. Okay, so we're going to have to square the 16, make that a 256. Okay, we're going to square the 10 and square the 9 and multiply 2 times 10 times 9 together. That's going to make this a minus 180. Now you're going to have to be careful here. You can combine the 100 and the 81, but you can't combine this minus 180 with that because it has a cosine of A connected to it. Okay, so we can make that 181, but we're going to need to subtract the 181. Okay, so we've got 256 minus 181. That gives you 75 on the left side minus 180 cosine A on the right side. Okay, now to move that 180 that's in front of the cosine to the other side, you're going to do that by dividing. Okay, because that's connected to cosine A by multiplication. Okay, now remember, we are trying to get this A right here by itself, and so what we're going to need to do next is we're going to need to do the inverse cosine. We have to do that to both sides. So what you're going to type into the calculator will be inverse cosine 75 divided by negative 180. Okay, we're going to round this up to the nearest angle. The measurement of angle A in this problem is 115 degrees. Okay, add that to the picture, and now we have enough information that we can press forward. Whoops, this was 115 right there. Okay, we can move forward with setting up now the law of sines. Sine of 115 over 16, I want to find the next largest angle next. So that would be angle C. So I'm going to do sine of C over 10. Okay, we will cross multiply. Divide by 16. Same thing here. Inverse sine. Squeeze this right in here. You're typing in inverse sine of 10 sine 115 divided by 16. This is going to give you an answer for the measurement of angle C to be 35 degrees. Okay, putting that on the blank, putting that on the picture, and now I add the two angles up, subtract 150 off of 180. That means angle B has to be 30 degrees. Okay. Okay, that one had a little bit more algebra in it because when you use the law of cosines to find a missing angle, you have to drag all these other numbers to the other side of the equation before you do the inverse cosine. We're going to try one more and then just talk very briefly about example 5 here. Okay, so on this one, again, this is another side-side-side problem. Okay, so I'm going to go ahead and draw a sketch here. This is triangle A, B, C. Okay, we're given the side A is 5, B is 11, C is 8. I want to tackle finding the largest angle first. That would be angle B. So I'm going to set up my law of cosines as side B squared all the way on the left. Then the other two sides are squared. Those are added together. Then I do minus 2 times each of the other two sides multiplied together, cosine angle B. Okay. So again, we're just going to kind of square off each of our numbers here first. We're taking minus 2 times 8 times 5, that would be negative 80, cosine B. I'm going to go ahead and add this together here. Okay, again, be careful, you can't subtract that 80 from 89. You have to move the 89 over separately. Okay, this gives us 32. And now we're going to divide by negative 80. And then we would finish this off by doing the inverse cosine of the fraction 32 over negative 80. Okay, this gives you the measurement of angle B to be 114 degrees. We're going to add that to the picture. Okay, now we should be able to do law of sines. Okay, I'm going to set up sine of 114 over 11. I'm going to find the next largest angle. That would be angle C. So sine of C over 8. Okay, now we're going to do the inverse sine again. And you would be typing in inverse sine, 8 sine 114 divided by 11. That gives you the measurement of angle C to be 41 degrees. Okay, if we add those two angles up and we subtract off of 180, it looks like that's going to leave us with 25 degrees for angle A. Okay, just looking at example B, we're actually not going to solve the triangle, even though it asks us to do that here in this example. I just want you to look at the information that you're given here, and I want you to simply make a determination whether you think that we could begin this problem by using the law of sines, or if we're forced to have to start using the law of cosines. Okay, so what we would be looking for is, do we know an angle, and do we know a side opposite that same angle? If the answer is yes, then we should be able to start out by using the law of sines. Feels like right here we know that angle A is 107, side A is 12, so I should be able to set up the law of sines like that as my initial step to begin solving the triangle. I don't think we need to use the law of cosines at all. Okay. All right, you can see that you have for your homework a worksheet titled Worksheet 12.5a.